we will solve this system of differential equation. But this is going to be a long problem because we have the non-homogeneous term and we have the initial conditions. So that's what we have. So let's just say this is the first equation and this is the second equation. And we're going to use all the space we can have. Right. So I continue. I start from here. The first equation, to rewrite that, we have dx. Let's move the 4x to that side and the y to that side equal to negative e to the 4t. And then second equation, ey minus x minus 4y equal to 0. Right, so have that step. Right. What we do next is we're going to simplify. Let's factor x out from the top equation. We have, factor x out of the equation. We have d minus 4 times x minus y equal to negative e to the 4t. And second equation, put negative x in front, and then d minus 4 times y equal to 0. I will eliminate x and then solve for y because it's easier to eliminate x. Actually, it is the same type problem. So I will multiply d minus 4 on the bottom equation. Note that I treat the differential operator d, it's just like a constant. So I just multiply instead of take derivative. So the top equation will stay the same. And the bottom equation have d minus 4x plus d minus 4 square y equal to 0. Then we add side by side. If we do that, we should have the equation. That's fine, just leave it for now. We should have negative y plus d minus 4 square, I have d square minus 16 minus 8d plus 16 y equal to 0. It's not 0, it is negative e to the 4t. Right. Add those side by side, we have that. Rewrite this equation. We have d squared y, which is second derivative of y, minus a times derivative 16y minus y, that is plus 15y equal to negative e to the 4t. Right. So we have a non-homogeneous equation. Now focus on this non-homogeneous equation. We do two parts. The first one is the homogeneous solution. Auxiliary equation give us auxiliary equation give us r squared minus ar plus 15 equal to 0. Factor out we have r minus 3 and r minus 5 is 0. So we have r is 3 and r is 5. And the solution, the homogeneous solution is C1 e to the 3t and C2 e to the 5t. Next, we solve for the non-homogeneous solution. I think we can continue on this side. Particular solution. Particular solution. We look at this equation and the form of the input function on the right. We can guess the solution is going to be equal to a times e to the 4t and then we can take derivative is 4a e to the 4t and the second derivative 16a e to the 4t. Substitute all of that into the equation. Into equation star, we will have the second derivative. So I will have 16a e to the 4t negative a times the derivative. Notice that we have the negative 8, so that gives us negative 32a e to the 4t, and then just a function, but times 15. So we multiply the function by 15 plus 15a e to the 4t. And this has to be equal to the input function on the right. So negative e to the 4t. Now combine everything on the left hand side. We will have just negative a e to the 4t equal to negative e to the 4t. So with that, a must be 1. So particular solution is going to be a is equal to 1, so e to the 4t. Right, so particular solution, homogeneous solution, add them together, we have y is equal to so now we have y equal to homogeneous solution and particular solution. C1 e to the 3t, C2 e to the 5t plus e to the 4t. Right? We have y. Now we solve for x. So for x, notice that now we have y. We look at those two equations and we're going to solve for x. Look like, or we can also look at the equation on this side. If we're going to solve for x, on the top equation we have x here and x here. Even worse, we have the derivative of x with respect to t. So if we're going to substitute y into this equation, if we're going to substitute y here, we have a differential equation for x. Now, if we solve for y, if we substitute for y, We only have one x here on the second equation. So the second equation is a lot easier to solve for x because x only appears once. So we're going to substitute into the second equation, which is derivative of y equal to x plus 4y. So we have that. And then we substitute into the second equation. Derivative of y equal x plus 4y. When we substitute that in solve for x, we can also say, why don't we just say it, x is equal to derivative of y plus 4y. Right? Now since we have the function, we can take the derivative. It's going to be 3c1 e to the 3t plus 5c2 e to the 5t plus 4 e to the 4t. That is the derivative. And then we will substitute the derivative into y here. And we have 3c1 e to the 3t, 5c2 e to the 5t, 4 e to the 4t. And plus 4 times the function. The function is this. And we have 4 times that. 4c1 e to the 3t, 4c2 e to the 5t, and 4 e to the 4t. And simplify this, we will have x equal to, right, just c1 and c2. So we have, this is c1 e to the 3t, c1 e to the 3t, 3 and 4, that will be 7. This we have c2 and e to the 5t. And we have 5 and 4, make it 9, c1 e to the 5t, and then 8. I forgot. Sorry. We have to subtract 4y on the right hand side. Right. So rather than multiply by 4, we multiply negative 4 into the function. So that would be minus 4 c1 e to the 3t minus 4 c2 e to the 5t and minus 4 e to the 4t, or negative 4. Right. Combine like terms. That is c1 e to the 3t. We have that too. 3 minus 4 is negative c1 e to the 4t, 3t, sorry. And then we have C2 e to the 5t here. 5 minus 4 is 1, so we plus C2 e to the 5t. We do have those cancel out. Yeah, because when I look at the initial condition, I see that it doesn't look like we have e to the t, e to the 4t for x. But anyway, so that's what we have for x. All right, so we have this is x. Right. Next, we will solve for the coefficient C1, C2 to have the initial value problem. Initial value problem, we have x is 0 equal to 3, y equal to 0, negative 3. So both of them equal to, I'm sorry, one is 3, one is negative 3. Okay. Right. X equal to 3. This is x. This is x. And that is y. So we're going to put 0 in for x. I mean for t. That is 0 for t of the x function. This one here. Negative c1 e to the 3 times 0 plus c2 e to the 5 times 0. And that's supposed to be equal to 3. So when we do that, we just have negative c1 plus c2 is equal to 3. Huh. For y, we have c1 e to the 3 times 0 plus c2 e to the 5 times 0 plus e to the 4 times 0 equal to negative 3. And when we simplify that, we have c1 plus c2. This is equal to 1. So we move that to the other side, we have negative 4. Alright. Add side by side because the c1 cancel out. We have 2c2 is negative 1. So c2 is negative 1/2. We have c2. We can find c1. So c1 we can say negative 4 minus c2. So negative 4 minus negative 1/2 is negative 7/2. Right. So we have c1 and c2, and substitute back into the equation for x and y. We have the solution. Remember, this is x, and this is y. So we say x equal to negative c1 give us 7/2 e to the 3t, and then plus c2. C2 is negative 1/2 e to the 5t, and that is x. Y, c1 is negative 7/2 e to the 3t. C2 is negative 1/2 e to the 5t, and then e to the 4t. So that is the end of the problem. I need to zoom out and see the whole picture. So I think that will be enough. Now let's just see what we have. Right. The first thing we do is we eliminate and so forth, eliminate x and so forth y. To eliminate x, I'm going to do this instead. So we eliminate x and so forth y. So we will have just highlight here. Right. So first, we eliminate x and so for y we have this non-homogeneous equation. We have homogeneous solution, particular solution. Combine them, we have y is going to be this. When we have y, substitute back, and we find x, which is this. When we have y and we have x, we can solve the initial value problem. T equal to 0, x equal to 3, y equal to -3, and do that, give us x and then y. And that's what we have for this problem.